Hello students, I am Dr. Shilpa K. Gowda, Associate Professor, Department of ECE, SJBIT. Today I am going to explain the topics related to integrated circuits, operation amplifiers and its applications. So these are the contents here, that is integrated circuit operation amplifiers, biasing operation amplifiers, voltage follower circuits, non-inverting amplifier, inverting amplifier, summing amplifiers and differential amplifiers. So integrated circuit operational amplifier. Here integrated circuit operation amplifier means opamp. Opamp means it is an amplifier which is basically an amplifier which is available in the integrated circuit form. The word operational has been used because this amplifier can be used to perform a variety of mathematical operations such as addition, subtraction, multiplication, division, etc. And also op-amp are commonly called as one of the basic building blocks of analog electronic circuits. Op-amp is basically a voltage amplifying device. Operational amplifiers. They are more commonly called as one of the basic building blocks of analog electronic circuits. They are used extensively in signal conditioning, filtering, or to perform mathematical operations such as adder, subtractor, integration, and differentiation. An operation amplifier or op-amp for short is fundamentally a voltage amplifying device designed to be used with external feedback components such as resistors and capacitors between its output and input terminals. These feedback components determine the resulting function or operation of the amplifier, and by uh, virtue of the different feedback configurations, whether resistive, capacitive, or both. The amplifier can perform a variety of different operations, giving rise to its name of operational amplifier. This is the basic building block of an operational amplifier. An op-amp is a three-terminal device which consists of two high impedance inputs. One of the input is called as the inverting input, marked with a negative or minus sign. The other input is called the non-inverting input, marked with a positive or plus sign. And also here And also this op-amp circuit mainly consists of the four different stages here, or four different blocks. Circuit symbol and a package. The figure shows the triangular circuit symbol for an integrated circuit operational amplifier. There are two input terminals, one output terminal and two supply terminals. The inputs are identified as the inverting input and the non-inverting inputs has a positive sign. A positive going voltage at the inverting input produces a negative going voltage at the output terminal. Conversely, a positive going voltage at the non-inverting input generates an output which is also positive going. Plus, minus supplies are normally used with op-amps, so the supply terminals are identified as plus VCC and minus VEE. So here this is two typical op-amp packages here for both the dual inline plastic package and the metal can package terminals. 2 and 3 are the inverting and non-inverting inputs respectively. Terminal 6 is the output and terminal 7 and 4 are plus and minus terminals here. This is the pin diagram of an op-amp. So here the pin configuration IC7 amplifier is shown in the below figure. The op-amp is IC number is 741 pin diagram, where first one is a power supply pin. Pin 4 and 7 is considered as a power supply pin, where pin 4 and pin 7 are the negative and positive voltage power supply terminals. The power which is required for the IC to function is received from both these pins. The voltage between these pins can be in the range of 5 to 18 volts. Output pin is pin number 6. The output which is delivered from the IC741 op-amp is received from this pin. The output voltage that is received at this pin is based on the feedback approach that is used and the voltage level at the input pins. When the voltage value at pin 6 is high, this corresponds that output voltage is similar to the positive supply voltage. In the same way, when the voltage value at pin 6 is low, this corresponds that output voltage is similar to the negative supply voltage. Next, we have input pins. Pin number 2 and pin number 3 are considered as input pins. These are the input pins for the operational amplifier. Pin 3 is considered as the inverting input, while pin 2 is considered non-inverting input. When the voltage value at pin 2 greater than pin 3, which means that inverting input has a high value of voltage, then the output signal is low. In the same way, when the voltage value at pin 3 is greater than pin 2, which means that the non-inverting input has a high value of voltage, then the output signal is high. Offset null pin, that is pin number 1 and pin number 5 is considered as offset null pin. As discussed, the operation amplifier has an increased level of voltage gain. Because of this, even minimal variations in the voltages at both non-inverting and inverting inputs, those are happened because of the abnormalities in the constructional procedure or other anomalies will be shown an impact on the output. In order to overcome this, an offset value of the voltage to be applied at pin 1 and pin 5, and this generally accomplished by a potentiometer. Not connected pin, that is pin number 8 is not connected pin. It is just a pin that is used to fill up the empty pin in the IC741 opamp. It has no connection with any of the internal or external circuits. This is an equivalent circuit of an ideal operational amplifier. An operational amplifier only responds to the difference between the voltages on its two input terminals, known commonly as the differential input voltage, and not to their common potential. Then, if the same voltage potential is applied to both terminals, the resultant output will be zero. An operational amplifier's gain is commonly known as the open loop differential gain and is given by the symbol A0. Next, we have op-amp parameters and idealized characteristics. Open loop gain. So here this is one of the parameter of the op-amp here. The main function of an operational amplifier is to amplify the input signal, and the more open loop gain it has, the better. Open loop gain is the gain of the op-amp without positive or negative feedback, and for such an amplifier the gain will be infinite, but typical real values range from about 20,000 to 200,000. Next, we have input impedance, that is, it is denoted by Zin. Infinite input impedance or impedance. Input impedance is the ratio of input voltage to input current and is assumed to be infinite to prevent any current flowing from the source supply into the amplifier's input circuitry. That is, real op-amps have input leakage currents from a few picoamps to a few milliamps. Next, output impedance, which is denoted by Z out. So here the output impedance of the ideal operation amplifier is assumed to be zero, acting as a perfect internal voltage source with no internal resistance, so that it can supply as much current as necessary to the load. This internal resistance is effectively in series with the load, thereby reducing the output voltage available to the load. Real op-amps have output impedances in the 100 to 20 kilo ohm range. Bandwidth. So here a infinite bandwidth. So it is represented by BW, that is infinite bandwidth. An ideal operational amplifier has an infinite frequency response and can amplify any frequency signal from DC to the highest AC frequencies. So it is therefore assumed to have an infinite bandwidth. With real op-amps, the bandwidth is limited by the gain bandwidth product, which is equal to the frequency where the amplifier's gain becomes unity. Next we have offset voltage, that is V naught. So here the amplifier's output will be zero when the voltage difference between the inverting and the non-inverting input is 0. The same or when both inputs are grounded, real op-amp have some amount of output offset voltage. Thank you.